the project coordinator of GIESEPP MP, which is one example of a project with electric propulsion we want to present today. And in particular, one example of a project within Horizon 2020, maybe as a background, Horizon 2020 is a EU, so European Union program. So it's not an ESA program, but also with a let's say one stream with a particular accent on space technology as a whole, and one set of projects within that are with regard to space propulsion, and more specifically to electric space propulsion, which is indeed something quite different, in particular to let's say the traditional liquid space propulsion. So maybe as an introduction, what is the project about? So first, this acronym GIESEPP stands for Gridded Ion Engine Standardized Electric Propulsion Platforms. So probably the important, or maybe everything is important, but here in our context, the particularity, it's focused on gridded ion engines. Gridded ion engine is one possible technology for electric propulsion, and at least for the mid and high power systems, there are substantially three different technologies that concur a little bit. It's gridded ion engine on one hand, it's Hall effect thrusters, and it's the so-called HAMT thrusters, which are the three major technologies that are followed. So what we try to do is, as a consortium of different European companies, to set up a system definition with our respective components, and to try to standardize as much as we can. At the same time, we try not to look only on one specific mission or one specific solution, but we try to define something that is to the maximum modularized, so we can have solutions for low Earth orbit, for a geo, or even for a deep space application. And by the modularity and the multi-company approach, one important aspect is also say we don't want to be a proprietary solution with one single source, which is always a problem within space business, to be single sources, and therefore that was also one of the major drivers to say let's go for a solution that enables different sources to have this system built up. In that context, in particular with regard to European interest, what we are looking for is really technology leadership in the fields of high ISP. High ISP, maybe also as an explanation, high ISP is the specific impulse, which is a parameter we use to, in particular in electric propulsion, but in space propulsion in general, to quantify the efficiency of a propulsion system. And that's the particularity of gridded ion engine, that this is a technology that offers the highest efficiency. Then number 4, in the same context, and that also already addresses one of the, let's say, the major paradigm changes in space business in general, maybe, but very much also for space propulsion, is to put an eye on high competitiveness with significant cost reduction. 30% is a lot when you have a product, to get ready for industrialization, and to use alternative propellants. And all these three are, what I would say, different from what we used to do until now. Traditionally, space propulsion was rather something that is done in small quantities and giving particular attention on quality, but less on cost efficiency and on industrial setup. And this is all currently changing for a couple of years, and this is what we're going along with. And number 5, the European independence, which is always a particular interest of EU-funded project, and which is of course very relevant for the space applications where we're dealing with, knowing that we're still relying on products that very often come from the US, and probably in particular with the US. Space products from US are typically export controlled and export restricted, meaning we as a company, if we buy US components, we always get into the danger that for some reasons, one day we might not get the products that we want because it's restricted and somebody within government has decided, no, it can't be exported. And this is what we want to avoid, because otherwise you're just stuck and you cannot go on with that. So that's the overall frame of our intentions. What's the ambition behind? So I think there are three pillars: technology, market, environment. I think for technology, I have addressed it already: standardization, improve European technology in general. A particular change also specifically with electric propulsion is that we set up the systems the way that we have multiple operating points. Operating points mean, yes, let's say the regime you want to drive your thruster. You can drive it either with a high thrust, but then less efficiency, or high efficiency, but then less thrust. And that has different impacts both on the thruster and on the system. And this is not what it used to be in the past. And in general, it's about strengthening the EP core competences. Understanding also, if you look at the market for space propulsion, and we're talking here about orbital propulsion, so we're not talking about launchers, we're talking about satellites or spaceships. So only things that that works under high vacuum in space. This has shifted, I would say, from what it used to be typically liquid or let's say chemical propulsion in the past. Since 5 to 10 years, there is a kind of shift with more and more electrical propulsion technologies taking over. Then the market topic I addressed earlier on as well. We shift from individual single part production to a more, let's say, classical industrial market approach. They say, I want to have ready-made products. I want to have them cheap. I want to have them quick, and I want to rely on that. And this is really a paradigm shift from what it used to be. Instead of saying, I make one individual or two individual or three individual products and they are individually looked after. This is what is currently changing. We need to make it much more industrial and much cheaper and much quicker. And the third aspect, the environment aspect, is also following, let's say, in particular the EU, but also the AETHER approach, meanwhile, with a particular focus and emphasis on getting green. So really taking care of what you do and what are the effects. And this certainly makes a big difference when you change from chemical propulsion to electric propulsion, which is substantially using solar energy for current generation on one hand, and uses harmless noble gas as the propellant. So which leads that we have really the least impact on the environment, even on the space environment, by getting there. So how are we set up in Horizon 2020, and normally in every EU project, you set up as a consortium. Consortium means we are different companies coming together as partners, but substantially everyone is working on its own responsibility, but with a common goal. So it's a difference to what you do with, or let's say, a normal industrial setup. We say, I have one prime, what do you say, prime contractor, and then you have subcontractor that are led by the prime. And here we are all partners on the same level, and we work on the same goal. In that particular case, you can see it here. We have Airbus Defense and Space in France taking care of the mission requirements in the system engineering, which is, let's say, their natural business as satellite manufacturers. We have ArianeGroup in Germany taking care of the propulsion or the thruster engineering to go for that platform. We have a test and scientific partner herein with the Justus Liebig University in Gießen, which is substantially partnering very close to ArianeGroup as the interaction for the thruster science, I would say. Then we have Aerospazio as the expert for system level testing, which is a very demanding task, meaning testing under space conditions, the complete propulsion system. GIESEPP in Spain is taking care of the power processing unit, which is also a very specific task, in particular to deal with this relatively high voltages under vacuum. And last but not least, we have Linda at Vidberry in Latvia taking care of, for example, webinars like those, but in general also on the communication and dissemination activities we have to show and to come up in that project. So yeah, getting back to the idea of the outcome of the project, in that context of those platforms that we have predefined, we will look for substantially 3 different kind of platforms. One platform at a 500 watt system level, which is rather the small and medium satellites, which are, let's say, down to a size of 250 kilogram. Then we have a medium size class, which is the 5 kilowatt system power solution, which is the one we are concentrating on in GIESEPP MP. And then we have a kind of extrapolation of this medium-sized system to a high power system, to a 20 kilowatt class system, which is typically foreseen for deep space applications, for very long and very, let's say, distant applications. And when we talk about platform, I would go really quickly over this. What we are dealing with, what you see here, is, let's say, the propulsion system as a whole. If we start from the right with the xenon tank, which is the propellant we use, you have on the left the spacecraft part, meaning the spacecraft interface, which is substantially okay, on one hand, the mechanical interface, on the other hand, all the intelligence that is linked to the onboard computer. And here in between, you have the propulsion system as a full system, starting here with the thruster. The thruster, in that particular case of the ArianeGroup application, consists of the thruster as such and a long-going RF generator. And with every thruster, you have a neutralizer that is integral part of the thruster in the end. You have a fluidic part, which is this one, which is taking care of preparing the xenon that is fueled into the thrusters. You have to regulate the pressure, and then you have to regulate the flow that you need this very precise. And the whole, let's say, the whole intelligence in that system is within the power processing unit that is feeding the electrical power to the system, and again integrating the whole intelligence and every regulation algorithm into this box, and the whole thing is then linked to the spacecraft. I would not go much deeper in that case and in the technology. Maybe when we come to the engineering role, we hear a little bit more about that.
Yes, Cyril, and you have to speed up, huh?
Okay. Yeah, then I will just jump over the platform modularity. Still reflecting a little bit the same that we said. Always this idea to be modular. So we have the 3 different platforms, we have different products, and then we want to have the possibility to interchange between different products to set up a platform. So it's not one fixed configuration, it's a possibility to pick out from a different range of components, like you would do for a car, for example. Then the way we have gone is shown here on that slide, where we assess the progress overall by TRL. So it's technical readiness level, which is an indication for the maturity of a technology. And you start typically at TRL 3 with doing the first hardware, which is the first experimental hardware, and then you want to reach TRL 9, which is a fully flight proven system and a ready-made product. And in between you have different steps. And currently we have gone from 3, 4 to 5, and now we're just going from 5 to 6 and 7, meaning we want to have a pre-qualified system to make it ready to really being integratable on the platform. I will not go on the details on that either. And yeah, in the end, it's about bringing in some innovation into the whole business. I think I've raised all the topics that are listed here. Okay, so that was about the project as such. I would just jump over at that time from the project to one possible role and possible work you can do in such a context. I will start with my own, which is the role of a project manager. So what does a project manager do in electric propulsion? And in space propulsion in general, and the answer is he does widely the same as every other project manager. It's all about typically what is called the magic triangle, meaning you have a contract. When you do a project, you have a contract. That's the starting point, and in that contract you have defined a certain scope we have to fulfill at a certain quality at a certain date, and you have only a budget available you have to go along with. And that's what you take care of. In the real life, it's rather a magic square, because the upper part is probably more the theory you might learn it at school. The practice is rather the lower part. We say you have a contract, but you have constant changes, and you have to adapt to those changes. And typically it is the dates are still the same, and you have change requests, and you have to make those changes real, while the initial task is demanding enough, meaning getting something done, typically a development and production, in that time with that cost. And this is what you have to take care of. So that's the substantial role of a project manager, what you have to keep in mind, which is, by the way, absolutely non-technical from the start. What are the typical tasks you have to go along as a project manager? I think that in one sentence is substantially make every stakeholder happy, which sounds good, but the problem is you have so many stakeholders that it seems sometimes an impossible task. So you have to be the interface to the customer. You have at the same time to be the interface to your management, and typically they have different interests. You have to be a risk manager, because there are, in particular in space, there is nothing you do without risks. You must be the planner, or at least understand to be the planner if you have a planner of your own. You have to control profit and loss. This is one of the substantial expectations from your boss. To my point of view, the main thing is to be the team integrator. In particular, the bigger the team is, the more this will take time to ensure that when you have many people working together, that they really work with the same aim and pull in the same direction. again, what I just mentioned, the constant changes are always a demanding challenge to manage. So it's not every change is a potential chaos, and this is what you have to take in hands and have control on it. And yeah, and in the end, this is the global expectation. You have to keep control over the project. That's your grand task as a project manager, to ensure the success of the project. And that's what I mentioned down there. The project success is widely the two first. You have to have a customer that is happy because he got what he wanted to, and you have to make your boss happy because you can tell we have earned money and not lost money. Yeah. Now, what does it take to get there? What are the competences you need? And by the very wide range of work you have as a project manager, your competences must be almost everything. I say the substantial thing is communication. For me, that's number one. Therefore, I put it as first on the list, because as you saw with all those stakeholders, to keep this under control, you have to be a good communicator. That's the major thing. You need to be a leader, integrator, because you have a team, and again, that's mastering complexity with people, meaning that's really dealing with people. And by the way, dealing with people is very often something in particular technical people are not very familiar with. That's my experience. I mean, I'm an engineer myself, but I realized that sometimes engineers, they love technology, but they are a little bit strange to working with people. Then you have to be overlooking what you do. In particular, when you have big projects, the complexity is immense, and you have big tasks, and you have very small, low-level problems people come up with, and it's your duty to make the difference. What do I have to take care of first, and what is second? Then you have to be foresighting, looking far away in the future as well. Typically, space projects can last for years. You have businesses where projects can last 3 weeks, 4 weeks. Typically in space, when you have a project, it lasts at least 3 years, 4 years, 5 years longer. Then it's all about money, because when you're in a company, the very duty of a company is earning money, and that's going through the project, meaning through the project manager. So you must be afraid of money, and at the same time, as the project manager, you always have to take decisions every day and be accountable for it. So taking the responsibility for your decisions. And last but not least, it's all about problem solving. Because when you don't have a problem and it's running, you don't need a project manager. The project manager is getting visible when you get problem and you need solutions, and you always have problems every day. And yeah, that's why I put it. It's either creativity, which is the good side, but it can be masochism, because sometimes you're just overwhelmed by problems. So that's really a project manager in a nutshell. Sorry if I had to be a little bit quick for that, but let's try to stick to the schedule. Happy to answer whatever question there may be.